One ignored warning, one misread signal, one skipped safety step. That's all it took to turn ordinary moments into the most shocking footage ever captured. These aren't just freak accidents caught on camera. They're reminders that the margin between routine and tragedy is thinner than anyone wants to believe. It was March 15, 2016, when Maxwell Sterling's shift at a Detroit automotive warehouse became his last. The 34-year-old forklift operator, known for his 8 years of meticulous safety practices and mentoring younger workers, had reported troubling creaking sounds from overhead beams that morning. His concerns were dismissed by supervisors. The 1980s-era building was buckling under extreme snow loads that exceeded its original design capacity. Investigators later estimated that accumulated snow and ice had reached over 40 pounds per square foot, nearly double the structure's rated capacity. Throughout the brutal winter, drifts had accumulated on the roof to dangerous levels. 6 months earlier, engineers had recommended reinforcing critical I-beams for $50,000, but management repeatedly delayed the repairs to avoid production shutdowns. Despite Maxwell's reservations about the hairline crack he'd spotted in a column cap, the crack ran across the top flange of a welded column cap, where a load-bearing beam seated directly against it, an area critical to the building's stability. He was assigned to the problematic East Bay, stacking 200-pound transmission cases 15 feet high with his forklift. Security cameras captured him following every safety protocol he'd learned over nearly a decade. The disaster began with an audible groan echoing through the warehouse. The primary support beam near the east wall, overwhelmed by snow load and structural deterioration, buckled under pressure exceeding its design capacity. Progressive collapse followed as one beam failure triggered adjacent connections to snap in rapid succession. Maxwell looked up as tons of steel decking, concrete, and twisted metal rained down. The protective overhead guard on his forklift was completely overwhelmed by the massive debris. Forklift guards are designed to deflect small objects, not multi-ton roof failures, leaving operators defenseless in a total structural collapse. The structure's open-web steel joists and corrugated decking failed sequentially, a hallmark of uncontrolled load redistribution. Steel beams and concrete slabs crashed with devastating force, pinning him against his seat and crushing him beneath several tons of wreckage. The sprinkler system activated, creating a misty haze that settled dust, but couldn't diminish the horror. Diesel fuel from the ruptured tank spread across the floor without igniting. Coworkers immediately called emergency services, their voices shaking as they described the catastrophic scene. First responders arrived within 9 minutes, but accessing Maxwell required 45 additional minutes of painstaking work. With hydraulic rescue tools, firefighters carefully removed tons of debris while avoiding further structural instability. Despite heroic efforts, Maxwell was pronounced dead at the scene from massive crushing injuries. The warehouse closed for months during a comprehensive safety review. Footage from the facility's security cameras, along with structural forensics, provided investigators with a detailed timeline of the collapse sequence, confirming that accumulated snow loads and corroded beam connections caused the structural failure. Regulatory agencies issued violations resulting in 7-figure penalties, while Maxwell's family pursued civil settlements highlighting company negligence. The facility underwent extensive retrofitting with new support beams, roof load monitoring, and improved procedures for employee safety concerns. Maxwell's death became a case study in deferred maintenance, reminding industries nationwide that ignored warnings often lead to preventable tragedy. It was August 22, 2017, when Anya Quinn's passion for capturing nature's hidden beauty led her to a remote Colorado mountain trail that became her final destination. The 28-year-old freelance photographer had built her career documenting untamed wilderness, specializing in landscapes few people ever witnessed. Anya possessed an adventurous spirit that defined her artistry but concerned those who knew her. She had completed over 200 challenging mountain trails, always pushing boundaries for the perfect shot. Her portfolio showcased breathtaking images from locations where most photographers feared to venture. That morning, Anya embarked on a solo expedition to document hidden Colorado for a travel magazine. The expert-rated trail featured a grueling 2,800-foot elevation gain over 6 miles of treacherous terrain. Despite rangers recommending against solo hiking on such dangerous routes, her confidence drove her forward. She carried 25 pounds of professional camera equipment, plus standard hiking gear. Her plan involved setting up an intervalometer-controlled DSLR on a tripod to capture sunrise over mountain peaks. Positioned across a canyon from protected nesting areas, clear morning conditions were forecast with possible afternoon storms. Anya had filed her route with authorities and carried emergency equipment, following most safety protocols despite hiking alone. The final approach required traversing exposed rock with ledges varying dramatically in width. Some narrowed to little more than a foot of uneven footing, where each step demanded absolute precision. Her remote camera captured her careful movements navigating precarious passages. The thin, alpine air and 6-hour climb had begun to sap her balance and fine coordination, small factors that often tip the odds on difficult terrain. At 300 feet above the valley floor, Anya reached a challenging section where the ledge narrowed to 15 inches. The location offered ideal vantage for photographing the canyon's geology, so she set down her heavy pack while framing shots. Working with her telephoto lens, Anya became absorbed in her craft, adjusting settings with meticulous attention. Focused on the perfect image, she stepped backward to improve her angle, not realizing the ledge continued tapering behind her. Her trailing foot found empty air where solid rock should have been. The sudden loss of support sent her tumbling backward off the precipice, camera equipment scattering as she desperately grasped for handholds. The fall lasted 4 to 5 seconds, including multiple impacts with protruding ledges that caused catastrophic trauma. Each collision with unforgiving granite inflicted devastating injuries, ensuring the cumulative damage would prove fatal. Anya's body came to rest in a steep, scree-filled ravine, nearly impossible to access without specialized rescue equipment. Scattered camera gear marked the fall line, creating a tragic timeline of her final moments. Her personal locator beacon activated upon impact, transmitting GPS coordinates to a satellite monitoring network. However, the remote location meant reaching her required 6 hours of careful navigation by mountain rescue specialists. When rescuers finally reached the ravine, they located Anya's body near her scattered gear. The recovery took several hours due to unstable rock and steep gradients, but her remains were successfully retrieved before weather conditions worsened. Data recovered from her equipment later helped investigators reconstruct the sequence of events, confirming she lost footing while repositioning her tripod along the narrowing ledge. According to the coroner's report, she sustained multiple blunt force injuries consistent with a multi-impact fall from approximately 300 feet. Rangers collected her gear during the follow-up recovery operation, and the final time-stamped images she captured were included in the official case documentation. Anya's last photographs were posthumously featured in the magazine as a tribute to her artistic vision, serving as a sobering reminder of the thin line between ambition and mortal danger in wilderness pursuits. It was June 8, 2015, when Owen Montgomery began what should have been another routine day operating heavy machinery at a Phoenix construction site. The 41-year-old crane operator had spent 15 years mastering his craft, building a reputation for precision and unwavering commitment to safety that had kept him accident-free throughout his career. Owen was passionate about his work and respected by colleagues for his methodical approach. As a devoted father of 3 teenagers, he often brought his children to completed projects, proudly showing them towering structures he had helped create. His dedication made him one of the most reliable operators on any job site. The construction project involved erecting a 12-story office building, presenting unique challenges due to a 69,000-volt transmission line running directly above the work area. The line carried 69 kilovolts phase to phase, typical for sub-transmission circuits feeding industrial zones. Federal regulations mandated maintaining minimum 20-foot clearance from all power lines during crane operations, a rule Owen had followed religiously throughout his career. That afternoon, Owen was training a young apprentice who observed his techniques. The apprentice watched as Owen prepared to lift a 40-foot steel I-beam weighing approximately 3,200 pounds, using his 200-foot tower crane. Weather conditions appeared ideal with calm winds and clear skies. The lift began smoothly, demonstrating the precise control that made Owen invaluable to construction crews. Multiple successful lifts earlier that day had proceeded without incident, reinforcing confidence in established safety procedures. As Owen rotated the crane boom to position the beam, an unexpected wind gust caught the load, causing it to develop a swing that reduced the critical clearance distance. Despite taglines designed to control movement, the beam's momentum created a dangerous situation that unfolded faster than safety systems could respond. The massive steel beam contacted the 69,000-volt transmission line, instantly creating a brilliant electrical arc visible from half a mile away. Nearby security cameras captured the blinding flash as the arc erupted, freezing the moment in stark clarity that investigators later reviewed frame by frame. An electrical arc exceeding 35,000 degrees Fahrenheit vaporized part of the steel surface and instantly ionized the surrounding air. Even though he was insulated from the beam, the current sought a ground path through the crane's frame, turning the cab itself into part of the circuit. Tremendous voltage traveled through the steel, down the crane's cables, and into the operator's cab where Owen sat. His body became part of the electrical circuit, receiving lethal high-voltage electricity that caused immediate cardiac arrest. The electrical surge created devastating burns, while the arc flash generated intense heat. The power surge triggered protective systems throughout the electrical grid, causing widespread blackout affecting 15,000 homes and businesses across the surrounding neighborhoods. Emergency responders arrived quickly, but could not approach the energized crane until utility crews confirmed the power line was de-energized. This safety protocol meant a 12-minute delay before paramedics could reach Owen. The apprentice and other workers could only watch helplessly from a safe distance. When responders finally reached the crane's cab, Owen had succumbed to massive electrical trauma. The combination of cardiac arrest, severe burns, and delayed medical intervention made survival impossible. The young apprentice who witnessed the accident was so traumatized that he immediately left the construction industry. The incident prompted immediate changes to construction safety protocols, including requirements for additional physical barriers around power lines and expanded clearance distances. Footage recovered from the site cameras provided investigators with precise timing of the electrical contact, confirming that a sudden wind gust reduced the boom's clearance below federal minimums. The official report cited unanticipated wind movement and insufficient tagline control as contributing factors in the fatal electrocution. Owen's family received compensation and pursued legal action, resulting in significant settlements. The project remained halted for 3 weeks, while investigators examined every aspect, ultimately leading to industry-wide improvements in electrical safety training and equipment design. It was October 14, 2016, when Stella Maris stepped onto the diving platform that would become the stage for her final performance. The 19-year-old competitive diver had dedicated 12 years to perfecting aerial acrobatics, transforming from an eager child into a formidable athlete with Olympic aspirations. Stella possessed technical precision and fearless ambition that separated elite athletes from competitors. Teammates knew her as a perfectionist who would repeat dives dozens of times until every movement flowed with mechanical precision. This relentless pursuit had earned national recognition. To support her expensive training, Stella worked part-time teaching swimming lessons. Her gentle patience with beginners contrasted sharply with fierce determination during practice sessions. The San Diego training facility featured a regulation 33-foot platform above a pool with the required minimum 16-foot depth. Security cameras recorded every session, allowing coaches to analyze technique. For 6 months, Stella had worked to master a reverse 3.5 somersault, one of diving's most challenging maneuvers. The dive required launching backward while completing multiple rotations before entering water vertically. 2 previous attempts showed promise, but contained minor deviations. Her coach harbored reservations about difficulty level, but recognized Stella's commitment to pushing boundaries. The reverse somersault demanded timing within hundredths of a second, any deviation risking a flat entry or over-rotation. Even experienced divers acknowledged inherent risks with such complex maneuvers. The afternoon session began with warm-up dives, establishing rhythm before attempting the challenging reverse somersault. Preliminary dives demonstrated excellent form, suggesting readiness. Safety protocols required trained spotters positioned around the deck during high-difficulty attempts, with emergency equipment staged nearby. When Stella climbed to the 33-foot platform, her movements displayed confident precision. She positioned herself at the edge, visualizing the complex sequence required for execution. Her approach and takeoff appeared flawless, launching backward with rotational velocity necessary to complete 3.5 somersaults. During the second rotation, a slight premature hip drop reduced her rotational momentum by roughly 10 degrees, just enough to prevent a vertical entry, proving catastrophic. Instead of entering water vertically, Stella struck the surface at shallow angle with her back and shoulders absorbing impact. The collision at approximately 31 miles per hour, the typical velocity from a 33-foot platform, generated tremendous deceleration forces her body couldn't withstand. Impact forces transferred directly to her upper spine, fracturing cervical vertebrae at the C2 to C3 level, an instantly catastrophic injury producing high cervical spinal injury. Her coach immediately dove into the pool, reaching her within seconds. Stella had become unresponsive and was sinking when he pulled her to the surface, while supporting her head and neck. Staff initiated emergency protocols, summoning paramedics while beginning rescue breathing. Advanced life support arrived within minutes, continuing resuscitation for 25 minutes before transport to the trauma center. Despite aggressive intervention, the combination of spinal injury and secondary drowning proved insurmountable. She was pronounced deceased at the hospital. The diving community responded with grief and immediate safety protocol enhancements. Teammates established an annual memorial competition, while administrators implemented additional safety measures. A review conducted by sport safety officials confirmed that a slight rotational underspeed during the reverse somersault caused a shallow angle impact consistent with fatal cervical trauma. Security footage became educational material, illustrating inherent risks. Stella's family donated her organs, allowing 4 others to receive life from her tragedy, ensuring her legacy extended beyond achievements to safety improvements throughout the diving community. It was January 19th, 2018, when Eliza Finch entered her laboratory for what would become her final experiment. The 26-year-old research chemist had earned her doctorate just 2 years earlier, but her innovative approach to developing eco-friendly industrial solvents had established her as one of the most promising young scientists in her field. Eliza embodied methodical precision that defined exceptional researchers. Colleagues admired her unwavering adherence to safety protocols and ability to identify potential hazards. Her meticulous documentation had prevented numerous accidents, making her the go-to mentor for newer laboratory personnel. The Atlanta Research Facility specialized in developing environmentally sustainable alternatives to traditional industrial chemicals. Her current project involved creating a biodegradable cleaning solvent to replace harsh petrochemical-based products. Her laboratory featured state-of-the-art safety equipment, including advanced ventilation systems, emergency gas scrubbers, and blast-resistant fume hoods designed to contain hazardous reactions. The reaction Eliza planned involved combining 3 chemical precursors in a temperature-controlled, pressure-rated, glass-lined reactor. The process required precise timing and careful temperature management to prevent the exothermic reaction from accelerating beyond safe parameters. Security cameras recorded all experimental activities. Eliza's colleagues worked in adjacent bays, separated by reinforced partitions, but close enough to respond quickly in emergencies. The procedure called for staged chemical additions at precisely controlled temperatures, with continuous monitoring of reaction temperature and pressure. Eliza had verified all safety systems before beginning, confirming ventilation, temperature controls, and emergency shutdown mechanisms were functioning properly. Initially, everything appeared normal. The chemical mixture heated as expected, and temperature readings remained within acceptable parameters. However, the reactor's PID temperature controller froze mid-cycle, halting coolant flow and allowing temperature to rise unchecked. The runaway exothermic reaction caused rapid pressure buildup as overheated chemicals produced expanding gases and vapors. Despite the reactor's pressure-rated design, an inch relief valve flange failed from stress corrosion cracking, preventing proper venting. When the vessel catastrophically failed, the resulting overpressure caused a brief but violent explosion that exceeded the fume hood's design limits, breaching its protective barriers. A small unshielded observation port, necessary for sensor calibration, created a path for the pressure wave and shrapnel to escape. The failure occurred at a gap in blast shielding where monitoring equipment required access, creating a pathway for high-velocity fragments and toxic vapors to escape containment. Eliza sustained fatal injuries from projectile fragments while suffering acute exposure to corrosive chemical vapors that caused severe respiratory damage. The combination created a medical emergency that would have challenged even immediate intervention. Laboratory alarms activated automatically, triggering emergency ventilation that increased airflow and isolated the affected bay. Hazmat specialists required extensive time to ensure safe atmospheric conditions before entering. When responders finally gained access, they confirmed Eliza had succumbed to her injuries. Security footage and sensor data from the laboratory allowed investigators to reconstruct the final minutes of the experiment, confirming that a frozen temperature controller and corroded relief flange caused the runaway reaction. The facility's final report cited both hardware fatigue and software oversight as contributing factors, leading to a full review of all pressure-rated systems. In response, the lab implemented comprehensive safety improvements, including redundant temperature monitoring, upgraded pressure relief routing, and mandatory full-height blast shields. Eliza's research team completed her solvent project using revised safety protocols, and the final product was patented with acknowledgement of her contributions. It was September 3rd, 2017, when Ronan Hayes arrived at the aging steel bridge that would claim his life. The 38-year-old structural engineer had built his reputation over 14 years by identifying critical infrastructure problems that others missed, earning respect for his thorough inspection methods and ability to spot potential failures. Ronan approached his work with dedication, understanding that lives depended on his assessments. Colleagues knew him as the engineer who would spend extra hours documenting every crack and measuring every deflection. This meticulous attention had prevented numerous bridge failures throughout his career. The 60-year-old steel truss bridge spanning a 200-foot river gorge outside Portland was scheduled for major renovations the following year, but routine safety inspections were required to ensure it remained safe. Weather conditions appeared ideal for structural assessment work. Overcast skies provided even lighting, while light winds created stable conditions for the suspended platform inspection system. Ronan's inspection used a motorized under-bridge inspection unit, suspended roughly 150 feet above the river. His safety harness connected to an independent vertical lifeline, anchored to sound structural members. The underbridge inspection platform's mounted camera documented his work as he recorded each structural detail for the project's digital log. The inspection focused on documenting corrosion patterns at critical connection points throughout the bridge's steel framework. His inspection revealed concerning corrosion levels at several critical joints, particularly where water drainage had concentrated over decades. Ultrasonic readings showed steel thickness reduced to less than 30% of the original design, an alarming loss of capacity. While photographing a severely corroded gusset plate connection, Ronan discovered deterioration more extensive than previous inspections had documented. The corrosion had significantly reduced the effective cross-sectional area of critical load-bearing members, creating a dangerous situation. As he positioned his camera to capture detailed images, the deteriorated connection suddenly failed under combined stresses. A 10-foot truss panel section suddenly gave way without warning, tearing free from the gusset connection. His safety harness line remained intact and properly anchored, but the sudden collapse created a pendulum effect that swung him laterally at tremendous speed. It held fast because it was clipped to an unaffected upper cord member, sparing him a full fall but not the lethal swing. Even though his vertical descent was arrested, horizontal momentum carried him directly into a massive concrete bridge pier with devastating force. The impact occurred at lethal velocity, causing traumatic injuries that would have been fatal regardless of medical intervention. Passing motorists immediately contacted emergency services, but the remote location beneath the bridge made access extremely challenging. When emergency teams finally reached Ronan, they confirmed what circumstances had made inevitable. According to the coroner's report, the impact caused multiple blunt force fractures and internal injuries, consistent with a high-velocity lateral collision. He was recovered from the suspended inspection platform after responders stabilized the remaining structure to prevent further collapse. The bridge was immediately closed and remained shut for 8 months, while repairs addressed the widespread deterioration his final inspection had revealed. Footage from the platform's mounted camera provided investigators with a complete record of the incident, allowing engineers to determine the precise sequence of the gusset plate failure and the resulting collapse. The official investigation concluded that advanced corrosion at the lower cord connection, combined with years of drainage-related metal loss, caused the structural failure that led to his death. His digital inspection files and the recorded footage became key evidence in confirming those findings. The engineering community responded with new safety standards for bridge inspections, introducing stricter anchor point requirements and clearer procedures for assessing swing hazards. Thanks for watching. Want to see more? Click on your screen now.